Continuing from the lesson from yesterday, we're going to just go through a little bit of extra work on prisms and how to find the volume of them. So this slide emphasizes how much a prism is literally just one single shape, but just sent into 3D. So for example, this triangle, if I slice it at the exact same sort of 90-degree angle to this, I should get the exact same shape there, like that. Likewise, if I do it with this pentagonal prism. So we're mostly familiar with triangular prisms, but if I've got a pentagonal prism as well, it's literally just that shape sort of made into sort of like a log. And a cuboid, I think we don't realize, is technically a rectangular prism, really, because it's just a rectangle just sent into the third dimension. You can almost imagine the 2D shape moving back and forward throughout the 3D shape, and it stays exactly where in its same the same orientation. And the way we find volumes then is we just have to find the area of this cross section, which is given in each of these examples, and then multiply it by the length of the cube, the prism. So here, the triangular prism has a cross-sectional area of 9 centimeters squared. We multiply that by our 8 centimeters, and we get 72 centimeters. Now notice, I've got centimeters squared times by centimeters. I get an extra power on my centimeters. They become cubes. Likewise here, I've got 15 centimeters squared multiplied by 9 centimeters. We get 9 times 5 is 45. Times that by 3, we get 135 centimeters cubed. And finally, the formula for finding the volume of a cuboid is the length times the width times the height. If you think about it, that's an area of one of its cross sections times by the third dimension. So here we've got 10 and 6 on here. Now the length of this cuboid we would say is the 6. So the 80 centimeters squared is the blue rectangle multiplied by the 6 centimeters, and that gets us 480 centimeters squared. So rule of thumb, find the area of a cross section the cross section that goes all the way through the shape, and then multiply by the length. So let's have a look at this here. I'll give you a bit of time to have a think about these yourself, or you can pause the video, have a think about these. So this question on the left, you've got an area 40 centimeters squared multiplied by the 15 centimeters, and you should get 600 centimeters cubed. Cool. And then this one, so you got, now the nice thing about this is the cross section here is a trapezium, but we've been given the area of the cross section, so we don't need any formulas to find the area of the trapezium. We just need to do 60 multiplied by 9 centimeters, which would be 540 centimeters cubed. And finally, you've got a triangular area and the prism's going down. This shouldn't really matter. Sometimes we say it's the height, sometimes we say it's the length. It's whatever is perpendicular to the cross section. So in this case, the length is the 11 centimeters. So we get 20 centimeters squared multiplied by 11 centimeters, which would be 220 centimeters cubed. Again, I'll give you a bit of time to try these ones. So this one, we know what the volume is and we know the cross-sectional area. We just need to know what the length was. So let's just say that this is x. I know that 45 centimeters squared multiplied by x is equal to 495. Well, I can do some division and say 495 divided by 45 is 11. So that length is 11 centimeters. Here, so I know everything the volume equals 360. And because I know that the area multiplied by the length makes the volume, I consider the volume divided by the length should be equal to the area. And how many 12s go into 360? Well, that would be same as 180 divided by 6, which would be 30 centimeters squared. Okay. All right. I'm not going to do the one on the left. Actually, no, I will do the one on the left because I think a few people have a few issues with triangles. So again, all we need to do to find the volume when we're not given the cross-sectional area is just to work out the cross-sectional area using what we know about 2D shapes and then multiply by the third dimension, which is normally the length or the height. So in these cases, I've got an area, which is a triangle, and I know that that is going to be a half times by 8 times by 7. I can do the half times the 8 first to get 4 times 7, which is 28 centimeters squared. Volume then is going to be 28 centimeters squared multiplied by that final length, which is 12 centimeters. And that would be... no idea. 56 times by 6, so that's going to be 336 centimeters cubed. If you're interested in what I did there, I doubled this number and then half that number. That will always give you the same answer. I think 56 times 6 is a little bit easier to work out. The one on the right then, I need to know the area of the circle. Now, the formula for the area of a circle is pi times the radius squared. In this case, it is 36 pi. Now, pi is 3.14 ... The more exact answer for the area is this. I know it looks like it's not exact, but that's the most exact we can write this. So we say 36 pi, and then the volume is going to be 36 pi times by 15. And in this case, that would be, 36 times 15 is going to be 360, 180, add them together, 540. So 540 pi centimeters cubed. Perfect. All right, I'll leave these for you. What I will say is on this one, don't forget the area for a trapezium. Is A, B. So the A and the B are your two parallel sides. You've got the perpendicular height. The area is going to be A plus B divided by 2 times by that height. I'll leave these with you guys. And then the next lesson I have you, I'll go through the exam style questions and the challenge. Cool.